So today we are from Group 5 and we'll be presenting our topic for the computational thinking with simulation of Indonesian toll booth system using Python coding. Alright, so first of all, I would like you guys to imagine a scenario where you're ordering a package online and you're so excited for this package to come that you keep checking the app every hour and what it keeps saying on the way. Now, what is taking the package so long? So, before the toll systems were invented, all types of vehicles had to be combined into these small crowded streets where vehicles such as motorcycles, trucks, buses, and also cars, they all had to be put in the same street. This leads to heavy traffic jam. That's why your package can take a really long time and even has a late arrival. So, the government came up with a solution by creating toll booth systems. So, Indonesia's toll road networks plays a vital role in supporting the mobility and logistics across the country. In West Java itself, the toll roads connect big cities such as Jakarta, Bekasi, Karawang, Bandung, and Cirebon. So over here you can see the map for the toll booth system in West Java. Over here there's Jakarta, and then there's Bandung, and also the other cities. Now, by developing this simulation, we aim to understand how toll systems determine fees based on distance and vehicle type. And we also apply computational thinking principles to model a real-life system. And then we also strengthen our ability to translate the daily processes into algorithmic form, for example, by using a flowchart. Now, we use the 4 steps in the computational thinking approach to approach the problem itself. First, we will be using decomposition, and the second we use abstraction, the third we use pattern recognition, and the fourth we use algorithm design. So, I'll start from the first one. For the decomposition, we break down the problem first by putting it into smaller components so we can solve it further. And for the second step approach, we use abstraction. Now for abstraction, we focus only on essential elements. For example, the cities, distances, and also the vehicle types. And for the third one, we use pattern recognition. For pattern recognition, we identify the reoccurring structures, and then the same logic applies for all of the routes and also the vehicle types. And for the fourth one, we use algorithmic design, where we design a clear step-by-step logic that connects the input, processing, and also output. Now, I will be explaining the step-by-step using flowchart. We have constructed the problem to a flowchart to make it easier to understand. So first, we start and we display the available cities, and we ask the user for entry and exit city selections. Now, it will ask if the route exists and is not identical. If it is not, then it will display error, and if it does, then it will ask for the vehicle class, and retrieve the distance and rate data, and then calculate the toll fee, estimate travel time, and then print toll receipt, and that's all.
So now I will be explaining how we do it in Python. So first off, I have defined here the distances between the cities. So I've inputted Jakarta to Bekasi, 21 kilometers, Bekasi to Karawang, 32, and so on and so forth. And to make this code more realistic, I have to consider what are the things a toll booth should include. One of them is vehicle classifications, because from vehicle classifications we can obtain the rates per kilometer. Therefore, I have created 5 vehicle classifications, which is the first class, cars, jeep, pickup. Second class, truck with 2 axles, and third, fourth, and fifth classes are pretty much truck with more axles. And since this is not a code that has since it's not a code that uses static data and it does not have real-time data, I would assume that the average speed of all vehicles are 80 kilometers per hour. Okay? And yeah, this is pretty much the code. It's pretty much basic syntaxes in Python, where I would only use if and else function. Alright, moving along. I'll show you the simulation and results of my code. I think this is better. This is better shown through practice. So we'll open up Python, we'll open up VS Code here, and I'll show you my code. So say that if we were to run this code, see, it gives us some of the drop-down menu. But since we're not able to use a GUI function, we're not able to use a GUI since we're not able to use graphic user interface, we decided to make it like this. We decided to print the whole thing so you can choose either Jakarta to Cirebon. Say that we would like to go from Jakarta to Bekasi. So enter the number of your entry city, which is number 1, Jakarta, and then our exit in Bekasi, and then it will ask our vehicle classification. We'll be going there by car. Here's the output. It will give you a color sheet where it tells you your entry city, your exit city, your distance, and vehicle classification. And from here, it gives you the calculation. So your rate per kilometer based on your vehicle classification, and then your total haul rate, which is based off your rate per kilometer multiplied by the distance. Now, as I said, since we do not have real-time data, our estimated time is based off my assumption of the vehicle going 80 kilometers per hour. Now, I would like to also show you how our code reacts to an error code. Say that you would have the same entry and exit city. Say that you were to enter in Jakarta and exit in Jakarta. So you would enter the number of your entry city 1 and number of your exit city 1. See, it will give an error code will pop up, and it will show the statement that an entry and exit cities cannot be the same. We also thought, wait, since our code simulation do not cover all distances of West Java, we also thought of that, and we decided to put an error code to routes that does not exist. And we'll gladly demonstrate that. So say that I want to enter in Jakarta, and I would like to exit in Karawang. See, there will be an error code stating that sorry, the route is not available in this situation. So yeah, this is pretty much our output. Yeah. Now, as I previously mentioned, our code has its own strengths and limitations. One of its strengths is that it is made out of simple syntaxes, resulting into a simple, clear, and easy to use code. And it also replicates a real-life haul model, since we have vehicle classifications, we use proper distances from city A to city B, so on and so forth. And personally, I think our code demonstrates computational thinking principles effectively. Also, however, just like any other thing, it also has its own limitations. So its first limitations is we only covered all systems in West Java, and based on the assumptions I made, we only use static data. There is no real-time updates, such as whether there will be traffic on roads, or there are any collisions or something that would prevent our journey to go smoothly. And also, it is not a graphic user interface. Okay, it is just a text-based console, so it cannot be as flashy as something you expect from a graphical user interface. All right. As for the conclusions and improvements, well, I'd say that our project has demonstrated how computational thinking and programming can model complex models into something that could be easily understood by the masses. And this could be done through decomposition, abstraction, pattern recognition, and algorithm design. And maybe in the future, we will improve our program by providing more routes, or perhaps using a graphical user interface. All right. Well, that's pretty much it for our presentation. Thank you very much.